Hi, this is Charles Jeffreys, and this topic we're still going to be talking about the brain and nervous system and neurobiology. And last segment we started talking about how the neurons communicate with each other. In other words, you have where the sending neuron axon goes and the receiving neuron's dendrite meet. Okay, we're talking about there's a gap there. In other words, when it's not being used, it's empty. That's what we call the synapse. Okay, I also mentioned that synapse is where the action is. Okay, that's where, in other words, the synapse is where the action is. It basically goes through, neurotransmitter fills a synapse, information fires across. Okay, it goes to the next neuron, it continues on down, but at the same time, reuptake takes place, where the neurotransmitters return to the storage places, and then the remaining neurotransmitters left in the gap get eaten up by the enzymes. So now let's talk about the neurotransmitter, that liquid or jelly substance that fills the synapse, which allows the neurons to communicate with each other. And you think about neurotransmitters, you can't help but stop thinking about drugs. Neurotransmitters, drugs, okay? Think about this in terms of every drug that influences your behavior looks like, acts on, or imitates one of these neurotransmitters, liquid substance that fills the synapse. Every drug that acts on, influences your behavior, acts on, looks like, or imitates a naturally produced chemical in your body. Think about natural high. In other words, meditate. Imagine you're high. It'd save a lot of money, wouldn't you? Okay, but think about that. Okay, this liquid jelly substance that allows the impulse to fire across to the next neuron. Okay, and we're going to look at a few of those. But before we talk about two classes of drugs, agonists and antagonists. Agonists, these are drugs that basically increase the firing of the synapse. In other words, versus antagonists, these are drugs that decrease the firing of the synapses. Agonists increase the firing of the synapses. Antagonists decrease the firing of the synapse. So caffeine, what do you think caffeine does? Let's see if you answer that to a certain extent. People, why do people drink coffee when you get up in the morning? Okay, versus sleeping pills, barbiturates. Okay, same thing. Okay, agonists versus antagonists. Agonists increase the firing, antagonists decrease the firing of the synapse.